Alright, so we're picking back up. We are still working on the hyperbolas. Notice on this equation that my y value is positive this time, so that's why it's up front. My x squared term is going to be negative, so it's behind. So this changes the direction of my hyperbola. Instead of being open from side to side, it's going to be open up down this time. Okay, so we're going to start it off in the same way that we did before. We need to come up with our center point. So our center we're going to gather from our parentheses, but since y value is listed first, you have to be careful about your center. The center y value has a 2, and make sure that you're putting it in the y position. And then this one is -4 for that. From there, so we're going to do that, plot it 1, 2, 3, 4, 1, 2. Okay, then remember the next thing that we need to do is move from the center point. So 36 is underneath the y. They tell me how to move up, down. And we're going to take the square root of that number. So up, down from the center, we're going to move 6. Okay, and then my x value direction that we're going to move left, right is 49. Take the square root, makes 7. A little bit off the graph there. All right, so from there, the next step is to change this into a rectangle. And remember, the rectangle is going to help us form our asymptotes because the diagonals of this rectangle end up being the asymptotes of my hyperbola. We're going to have one asymptote that has a negative slope. And asymptotes are dotted lines. Make sure you're dotting. I'm going to do my positive slope asymptote in blue. Okay, since my y squared term is the positive set, that means the points that were plotted in the y direction end up being the vertices. So I'm going to make them super big because these are going to be my vertices. We're going to have V1 coordinate and a V2 coordinate then. Right, so these vertices share x values for my center, and they differ in y values, right? So we were traveling 6 up and 6 down from the center point 2. So 2 minus 6 ends up to be -4. And 6 up from 2 makes 8. And then you're going to draw in your hyperbola and make sure that you are curving it towards the asymptotes. This is how it's different from a parabola, right? Because the asymptotes help shape your curves. All right, from there what you're going to do is find the equation of your asymptotes. Remember, it starts off with the slope. So the numbers on the bottom tells you how we moved in each direction. Slope is rise over run. Rise is your up-down movement. Run is your left-right movement. So my slope is going to be 6/7 or -6/7. So my positive slope is 6/7 and my negative slope is -6/7. Then we're going to substitute values into our point slope form, and that should be easy to then change that form into slope intercept form. So I want you guys to try that and then hit pause, right, so that you can check your answers with me in just a minute. All right, so check back in with me, make sure that you got these equations for your asymptotes. And there's the work shown there. So that finishes up our hyperbola examples. All right, so now moving on to the last conic is the parabola. So in the beginning of the year, we did quadratics and we did quadratic functions. So the ones that you're used to doing is the vertical ones, right? Remember, up front is your scale factor. Since it's positive, that means my parabola is going to be opening upward, right? And remember, these help form the vertex. And this one is in parentheses, so we have to do the opposite of what it is. So my vertex is 3, 5. Alright, and then from there what we need to do is talk about how we move from the vertex to get our other points. Since this is based on the parent function x squared, that means from the vertex we move over 1, up 1. From the vertex we move over 2, up 4. Over 3 from the vertex, up 9. Over 4 from the vertex, up 16. And notice how all of these are perfect squared numbers. Alright, so from the vertex we're going to move over to the right one, but instead of going up 1, since we have a scale factor of 1/2, we're going to go up half. And then we're going to go over 2 and up 2 because of my scale factor of 1/2. Then we're going to go over 3 and up 4.5. So there's the right side of my parabola, and it is symmetrical, right, about the vertex, so I'm going to reflect my points and connect. And there's my parabola. So to get full credit on the parabola graphs, you just need to tell me where the vertex is and make as many marking points as the graph allows. Alright, now for the horizontal parabola. Notice how your equation starts off with x equals stuff. So because of this, that is an indicator that I am going to be opening either to the right or opening up to the left. Because my scale factor is positive, that means I'm going to be opening in the positive x direction, which is to the right. Okay, so we're going to get our vertex kind of in the same way, but this 3 is attached to the y. So for my vertex, 3 belongs in the y position. This 2 is in the x position. Okay, so over 2, up 3. There's the vertex. I know I need to be opening my parabola this way. Okay, we're going to do our parent function movements and scale it by 2 this time. And for me, it's a little bit easier if I turn my paper this way so that I can still do the over 1 and up 1 parent maneuvers. So we're going to go over 1, and instead of up 1, we're going to go up 2 this time. And over 2, and instead of up 4, we're going to go up 8, which takes me to the end of the graph. So those are all the points that I can do. And then we're going to reflect those points, connect our dots in a parabola shape. So there's my horizontal parabola. And you can get these parent functions from the notes, the note sheet that I gave you today. Alright, so now moving on to some other ones here, other parabolas. Alright, so I have another one. Example number 8 is an x equals, so that means I'm going to be opening either left or right. Since my scale factor is negative, it means I'm going to be opening to the left this time. Alright, so we're going to get our vertex first. So my vertex is going to be 1, -5. Remember, this is the x value. This is grouped with a y, so it's a y value. It's going to open to the left, as we discussed, because of the scale factor being negative. The dilation is 1/4. So let's plot our vertex. 1, 1, 2, 3, 4, 5. Okay, this time we're opening to the left, so I need to rotate my paper this way. Okay, and then I'm going to travel over 1, and instead of going up 1, I have to go 1/4, which is kind of a little bit hard to do. Alright, so then we're going to move over 2, and instead of going up 4, I'm going to go up 1, because that's 1/4 of 4 is 1. I'm going to skip 3, because it's going to be kind of funky like this one. Let's do the over 4. So if I move over 4, I normally go up 16, but I have 1/4 of that, so I'm going to go up 4. Okay, if I go over 5, I would have to go up 25, and 1/4 of that is kind of funky, so let's do 6 then. If I go over 6, 1, 2, 3, 4, 5, 6, I normally go up 36, but 1/4 of 36 is 9, so I'm going to count out to 9. and then I've run out of room for my graph. So then we're going to mirror image those points, and maybe I'm going to leave that one off because that's really hard to do 1/4 on these itty bitty grids. And then we're going to connect our points in a parabola shape, like that. So when we turn our paper right side up again, it's opening to the left like we said it should. Alright, so the next example is y equals, so this means I'm going to be opening either up or down, and since my scale factor is -4, that means it's going to be opening down. My scale factor is 4. Okay, we're going to get the vertex this way. So x value is 3, y value is 8. So we're going to go over 3, up 8. Okay, so from there we're going to move this time, going over 1 and working our way down because it's supposed to open down. So we go over 1, and normally we go down 1, but I have a scale factor of 4, so now I have to go down 4. So 1, 2, 3, 4. Then we go from the vertex over 2. Normally on the parent function we would go down 4 next, but I'm traveling 16 this time. So that one was 4, so 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I ran out of room. We're going to mirror those points, reflect them, and connect our points in a parabola shape. So that concludes our parabola examples. Alright, so the next set of examples is going to be kind of working in the backwards direction. We have a graph, and now I have to write the equation of the graph. So to be able to do this, first you have to identify which conic section it is, right? This is a parabola. It opens in the right direction. So if you look back at your conic section formulas, right? Parabola that's opening in the left-right direction is our horizontal one. So the general format should look like this, right? So I'm going to copy that on the top up here. So x equals a times y minus k squared plus h. Because it's opening to the right, I know that a has to be a positive number. Okay. Next, what I need to do is identify the vertex, because the vertex is the k and the h value. Be careful that you're substituting the x value into h and the y value into k. So this vertex has the coordinate of -4, 2. So when I substitute into my equation, we're going to write y minus 2 quantity squared minus 4. Okay, all I need to do now is check for the scale factor. So I'm going to turn my paper sideways, and on my parent function I'm supposed to move over 1, up 1. It looks like that's what's happening. I'm going to check again, over 2, up 4. Looks like that matches the parent function. I'm going to check one more time, over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I feel confident that this matches the parent function, which had a scale factor of 1. So 1 technically goes there, or you can write it without the 1 because that's always implied. Okay, so number 11 is the ellipse. And the ellipse has two different standard, depending if it's horizontal or vertical. And this one is a horizontal one, right? So we're going to follow this format here. So I'm going to write that first on the top. It should be x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. So it's got to match this.